Saxon's Trig, lesson 27, begins with related angles and then moves to signs of trigonometric functions. It begins on page 188. Related angles deal with vectors. So if they give you a 12 with 135 degrees, you would begin to graph on your Cartesian plane starting at the 0, 0 line. This would be the 90. This would be 180. This is 270. This one is 360 when you wrap around. So this 135 is past the 90, but before the 180. So I'm moving 2 here. This is the 135 degrees. I'm connecting my triangle always down to the x-axis, forming the right triangle. Now, in order to find what the degree is inside of this triangle, I need to do 180 minus 135, and I get 45 degrees inside the triangle. This is what they call the related angle. So even though my problem is originally given in 135, 45 degrees is the one that I use in the solution part. So I get the answer if I'm converting it over to its I and J rectangular coordinate format, if that's what I need to do. But for this, all they're doing is giving you the term related angle. So their definition at the very last sentence in the section says that the related angle is always a positive angle, yes, and is the acute angle, yes, that's acute, between the vector, the line, and the x-axis. So it is always saying it's the gap between the hypotenuse vector line and the axis, the x-axis that it's connecting to. And that's all they're really doing here, is giving you that term and explaining it. In section B, they mostly change gears, and they begin to talk about the signs of the trigonometric functions. So for some reason, they introduce this in kind of a memorize this information kind of a way, and then later on they give you the shortcut that I'm going to go ahead and give you. I just think it makes it easier to do it all from the get-go. So in these 4 quadrants, the first quadrant, I'll label them quadrant 1, quadrant 2, quadrant 3, quadrant 4. And hopefully you remember that you always go around counterclockwise, and this is always your starting place. So all of your sine, cosine, and tangent words fall in quadrant 1 and are positive here. All students. This means that the sine, and then later its opposite, which you don't know yet, will be the only one that is positive. All students take. Tangent is the only one that's positive here, calculus. I realize that's not a truthful statement, but you'll hear me say it enough that hopefully I'm hammering it into your head. All students take calculus beginning with the C, so that's the cosine one. So this means sine, cosine, and tangent. All of them are positive in the first quadrant. So let's get practical here now that you understand. Oh, no, I should say one other thing. None of them will be negative here, but if only sine is positive here, then in quadrant 2, the negative words will be cosine and tangent. Here, the negative words will be sine and cosine, and here the negative words will be sine and tangent. So it works the opposite, but we're going to memorize it with the positives. All students take calculus to help us get this memorized. So the question in example 1 says, evaluate 4 cosine of 135 degrees. That's almost this one, except that the 12 has been changed to a 4. So let's go ahead and use this graph here. At 135 is already graphed. We've already figured out the gap between the 180 is 45. So let's finish labeling what these parts are. Both legs on a 45 are 1, 1, and the hypotenuse is radical 2. Now, because I'm in an actual quadrant with this memorized triangle, I want to write down the signs. So this one is negative, this one is positive. Your hypotenuse will always be positive unless we're altering quadrants, but don't worry about that at this point. Now that we've labeled our parts, what is the cosine of 135? Cosine is ca, so adjacent over hypotenuse. Adjacent is Now it does matter which one I'm pulling because this one has a negative. So my fraction is -1 over the hypotenuse of root 2, and that is multiplying by 4. -4 over root 2, multiply by root 2 over root 2 to simplify that. And that's going to give you -4 root 2 over 2, which will simplify to -2 root 2. So it matters which quadrant that I'm in. The word cosine here, when I got that answer, was it positive? Nope, it fell under a negative, so it had a negative. Do I need to memorize all of this in order to figure out it's positive and negative? No, when I get here and I label it correctly, I can just pull what I need. Example 2, -2 cosine of -150 degrees. So when we go to graph -150, I'm still starting at the 0 line, but now I'm working backwards. So this becomes -90, -180, -270, -360 when I get back around. So I'm going to go negatively 150. It's past the 90, but before the 180. So I know that this is -150 degrees. Finishing my triangle connects always to the x-axis. How much is the gap from 180 to 150? 30 degrees. So I want to label opposite my 30 is a 1, adjacent is the radical 3 because this is the 60, and then my hypotenuse is 2. Want to label the signs correctly. This one's negative, this one's negative. Let me pause here for just a second. Make sure that everyone knows the labeling of, let me go back up here. So even though I said everything's positive here, this is a positive x and a positive y in this quadrant, positive over positive up. This one is a negative x and a positive y. This one is a negative x and a negative y, and this one is positive x, negative y, in case that is helpful for you to know the signs on the quadrants. All right, so that's how I'm getting these labeled as both negatives because I'm in quadrant 3. Okay, now cosine, ca wants adjacent over hypotenuse. The adjacent to 30 is negative radical 3. The hypotenuse is 2. And that is supposed to multiply with this -2. Going to cancel or reduce the 2's. Negative times negative is positive, and the only thing I kept was the radical 3. All right, example 3. They want 5/3 cosine of 300 degrees. This is a positive degree, so I'm starting here, going around. So I'm past the 90, the 180, and the 270. So I'm here, so I've used up 300 degrees, going around that far, connecting my triangle to the x-axis. This is 360 if I go all the way around, so my gap is 60 degrees. Opposite the 60, root 3. Other adjacent side would then be 1, hypotenuse is 2. Label, this one's positive, this one's negative. Okay, now we've labeled everything. Cosine, again, ca. Adjacent, the adjacent to this is 1, the hypotenuse is 2. So we're filling in 1/2 and multiplying that by 5/3, nothing to reduce. So I get 5/6 as the final fractional answer.